Welcome to the Calculus C section. In this section, we'll be discussing series. So now that we've learned about sequences and we are aware of the terms to denote a certain order of a sequence, we will learn about series, which is a combination of infinitely many quantities one after the other. So here's an example of a series. We can have S1 is equal to A1, S1 is equal to A1 plus A2, S1 is equal to A1 plus A2 plus A3, S1 is equal to A1 plus A2 plus A3 plus A4, and so these are just a sequence with one term, a sequence with two terms, a sequence with three terms, a sequence with four terms, and a Sn is denoted by A1 plus A2 plus A3 plus A4, plus infinitely many sums is equal to the sigma of n I equals 1 for ai, which is however many i's you would like. So the following s's are depicted and are partial sums for the following sequence if we wanted to denote it by Sn. And we can say, since we went up to four terms, 4 and n is equal to 1. So that is what our sequence was, and if we were to add all of them up, it would look something like this. But what we want to get to the idea of is infinite series. So an infinite series is denoted by the following. So a general series would be n, I equals 1, and then we had ai, but an infinite series would look something like this. n, I equals 1, and we want our top function actually, instead of n, we want it to be infinity. So we're going to say that this is actually, infinity, and we're dealing with a to the n regarding an infinite amount of partial sums. So essentially it would look something like this s to the n idea. And so series are written in all different types of notations, and it's important to note that they are often, more often than not, the same thing. So don't be intimidated by a new formed notation. So we can say that instead of I, maybe we wanted this to be J. Instead of J, maybe we want it to be W. Maybe we want this to be alpha, which generally you wouldn't see because it's denoting of an angle. Or maybe we want it to be, I don't know, theta or Z. But anyways, it doesn't matter what our series is. We can say, we can change up what is in the continents. Instead of an, we can say maybe it's 1i squared with regards to I is equal to 1. And then this is an infinity or n equals, but it doesn't really matter. All that is important is that you understand what is going on inside the series and what everything means. So let's break down the nuances of a series. So our index is given by I, our index of our series, which indicates where our series starts, okay? So in every time that we said that n is equal to 1, we would start with our first term here, and we said we wanted to go to 4, and that was where we stopped. So that is our constraint or our limitation. And our function is given by an or ai. Our function is what we are plugging in these numbers to and determining what our first order sequence is, or our first or second order, third order, or whatever, or vice versa. So some properties of sequences, or series, my apologies, are if the sigma an and the sigma, let me rewrite that, and the sigma bn are both convergent series. And as we learned that in the previous, a convergent series is something that, or a convergent sequence is something that approaches a whole value or a certain value. Similarly, in series, a sequence or a series that is convergent is a series that no longer approaches a infinitely expanding value, whereas a divergent series would be something that continuously expands regardless of the term. So if we were to say an and bn are both convergent, then we can say if we had something like the sum of c to the times an, this can actually be written as c sigma an. Similarly, if we had something along the lines of adding these two, if we wanted to add an bn, it would also be equal to an plus or minus bn. We wouldn't have to separate the series. So what's important to note about, additionally, if we wanted to regard multiplication, we need to understand that if we wanted to do e to the an, that's written poorly, but multiplied by e to the bn is not equal to sigma an bn. These are not relatable concepts. And if the partial sums is convergent, which means the limit exists, it is a finite, then the series is also called convergent, as previously stated. And if the sequence of the partial sums is a divergent series, its limit does not exist, or it is infinity. It's called divergent. And what's important to note is that a series is just a sequence with additive sums. So in prior, we would look at a sequence and say that, okay, we want, like, it would be 1, 2, 3, 4. If we had that same thing with a series, it would be 1 plus 2 plus 3 plus 4, and that would be 3, 6, 10. And that would be our series. So that is it for the lesson. If you need additional information or more problems to do, there is a bunch on the website. I hope that helps.